Welcome to AMAC KSSM channel. This is KSSM at Max Form 5 exercise discussion. And Madam Wong
exercise 6.9. Number 1. Without using a calculator, determine the value of each of the following. A. 2 sine 30 degree, cosine 30 degree. From 2 sine 30 degree and cosine 30 degree, we can see sine 2 times of 30 degree is applied. So, sine 2 times of 30 degree is sine 60 degree from the equilateral triangle, and we can know sine 60 degree is sec 3 over 2. B. Cosine square of 165 degree minus sine square 165 degree. So this is cosine 2 times formula, where we have cosine 2 times of 165 degree. So we can get it cosine 330 degree. So cosine 330 degree is in fourth quadrant. So if we change it to the corresponding reference angle, it will be 360 degree minus 330 degree, and we get 30 degree. And cosine in fourth quadrant will be positive. So we have cosine 30 degree. So from this triangle, we know cosine 30 degree is sec 3 over 2. C. 1 minus tangent square of 75 degree over 2 tangent 75 degree. So from here, we can see that is the flip of 2 tangent 75 degree over 1 minus tangent square of 75 degree, which is 1 over tangent 2 times of 75 degree. So we have cotangent 150 degree. So cotangent 150 degree in second quadrant. So the corresponding reference angle here will be 30 degree. So we can change the cotangent 150 degree with cotangent 30 degree and the negative in front. So we have negative of cotangent 30 degree. So come back to the triangle. Cotangent 30 degree will be adjacent over opposite. So we have negative sec 3. Question number 2. Prove that cosecant 2a equals to 1 over 2 secant a cosecant a. So we start from the left hand side so that we can expand with the double angle formula. So cosecant 2a is 1 over sine 2a, which is 2 times of sine a cos a, where we can separate this fraction into 1 over 2 times 1 over sine a times 1 over cosine a, where we will get 1 over 2 times secant a and cosecant a. So proven. Question number 3. A. Prove each of the following identities. A. Sine 2 theta times tangent theta plus cotangent theta equals to 2. So we'll start from the left hand side because we have double angle formulae and we can expand it. So sine 2 theta is 2 times of sine theta cos theta, and tangent theta plus cotangent theta, we change it into sine theta over cos theta plus cosine theta over sine theta. So from here, we make the denominator common. Alright, so we have sine square theta plus cos square theta over sine theta cos theta, where the sine theta cos theta here, I can simplify with the sine theta cos theta outside. So we have 2 times of sine square theta plus cos square theta. So we will get 2 factorized out times sine theta square plus cos theta square, and we will get 2. B. Sine 4x plus sine 2x over cosine 4x plus cosine 2x plus 1 equals to tangent 2x. So we'll start from the left so that we can expand the 4x by 2 times of sine 2x cosine 2x, and then plus the sine 2x. Down here, cosine 4x plus cosine 2x plus 1, we expand cosine 4x with 2 cosine square of 2x minus 1 plus cosine 2x plus 1. So from here, we can factorize out the sine 2x and cosine 2x. and we will get the common factor of 2 cos 2x plus 1 and 2 cos 2x plus 1, and we can cut it off, become sine 2x over cosine 2x, which is our tangent 2x. Proven. C. Cosecant 2a plus cotangent 2a equals to cotangent a. Same thing, we start from the side with double angle. So cosecant 2a is 1 over sine 2a. Cotangent 2a will be cosine 2a over sine 2a. So now we have 1 plus 2 cosine square a minus 1, which is the expansion from cosine 2a, and then over the common denominator with the expansion of 2 sine a cos a. So after simplifying on top, we will get 2 cosine square a over 2 sine a cos a. So cut off the common factor and we left cosine a over sine a, which is cotangent a. Proven. D. Secant 2x equals to cotangent x plus tangent x over cotangent x minus tangent x. So start from the right hand side, okay, so that we can change the cotangent tangent into sine and cosine. So start from the cotangent x, we have cosine x over sine x plus the tangent x, which is sine x over cosine x, then over cosine x over sine x minus sine x over cosine x. So to make the denominator same, we times sine x for this fraction and cosine x, we'll times cosine x for this fraction and we'll times sine x for the second fraction. So we'll get cos square x plus sine square x over sine x cos x. Below, same thing, the first fraction will times cosine x and the second fraction will times with sine x. So for the first fraction down here, we'll get cosine square x minus second fraction here, sine square x over the common denominator of sine x cos x. So with the two layer of fraction, okay, we have same denominator, so we can cut off the common factor. And the cosine square x plus sine square x is equals to 1. So now we have 1 over cosine square x minus sine square x, which is 1 over cosine 2x. So therefore, we will get secant 2x. Proven. Number 4. Given sine x is 4 over 5, where x is an acute angle. So when x is an acute angle, we know x is falls in first quadrant. So we sketch our triangle in the first quadrant with the side given here, opposite 4 and hypotenuse 5. So from this two, we can calculate the adjacent 3 with the Pythagoras theorem. Then sine y equals to 5 over 13, where y is an obtuse angle. So obtuse angle is that angle greater than 90 and less than 180. So we know y is in second quadrant. So in second quadrant, we can get our reference angle here. So by sketching the triangle of y, we have opposite over adjacent, and we can calculate the opposite over hypotenuse, and we can calculate the adjacent. So remember to put a negative for your adjacent because it is on the left of the Cartesian plane. Alright, so now we need to find the value of cosecant 2x. So first, we change the cosecant 2x into 1 over sine 2x with the expansion of 2 sine x cos x. Then we will find the value of sine x from this triangle, which is 4 over 5, and cosine x is 3 over 5. Therefore, we have 1 over 2 times of 4 over 5 and 3 over 5. So simplify the whole fraction, we get 25 over 24. B. Secant 2y. So secant 2y is 1 over cosine 2y, where we can expand the cosine 2y with cosine square y minus sine square y. So refer to the triangle with angle y. So we get 1 over cosine y, which is negative 12 over 13, and square it, okay, minus sine square y. So 5 over 13 with the square outside. So now we have 1 over 144 over 169 minus 25 over 169. So simplify the fraction, we'll get 169 over 119. C. For sine x over 2 and y tangent y over 2, C and D, okay, so we can use the double angle formulae, okay, which I see x is actually double of x over 2. Y is actually double of y over 2. So we start with the cosine formula, cosine double angle formula that relates cosine and sine. So from here, cosine x we can find from the triangle, okay, which is 3 over 5. So cosine x equals to 1 minus 2 sine square of x over 2. We change the cosine x into 3 over 5 equals to 1 minus 2 times of sine square of x over 2. And we can get 2 sine square x over 2 is 1 minus 3 over 5, which we get 2 over 5. So sine square of x over 2, which we will get 1 over 5. And then we know if we remove the square here, it will be positive or negative of square root 1 over 5. But check back our domain. The x is an acute angle. What happened to x over 2? If the x is an acute angle, which is from 0 to pi over 2, then when it's half x over 2, then the range of x over 2 will be from 0 to pi over 4. So still this angle in first quadrant. Therefore, we only get the positive value of sine x over 2, which is 1 over square root of 5, where we rationalize the denominator, we will get 5 over 5. Tangent y. From the tangent double angle formula, tangent y is 2 times of tangent y over 2 over 1 minus tangent square of y over 2. So we have a quadratic formula. By changing the tangent y from here, 5 over negative 12, okay, then we move the denominator 2 times with the fraction on the left. So negative 5 over 12 times 1 minus tangent square of y over 2, we will get 2 times of tangent y over 2. So when we times in, the negative 5 times negative tangent square of y over 2, we get positive 5 tangent square y over 2 minus 12 times 2, we get 24. Move to the left, we get minus 24 times of tangent y over 2, and the negative 5 times 1, we get negative 5 equals to 0. So you will see I already rearranged the quadratic equation. So factorize this quadratic equation, we'll get 5 tangent y over 2 plus 1 times tangent y over 2 minus 5. Then, as we see, we check on the range of y. The y is an obtuse angle. So, to be exact, y will be pi over 2 to pi. Then, if the y become half of it, pi over 2 will be pi over 4. So, the y over 2 falls in the range of pi over 4 to pi over 2, which is still in first quadrant. So, if the y over 2 is in first quadrant, then the tangent value of y over 2 will be only positive 5. That's all. Thank you.